Alright, so here's our first example. Completely simplify each radical. Assume all variables represent positive values. Okay, so we don't have to worry about making anything positive in the end. Right? We just have to worry about simplifying the radical. So let's start with our square root of x to the 10th. Now, the first step here is going to be to break the x to the 10th down into all of its factors. Okay, so the square root of x to the 10th is actually the square root of x multiplied by itself 10 times. So here's my factored form. Next, after we factored our radicand, the number underneath the square root, we have to circle groups of 2, right? Because this is a square root. So we have 1, 2, 3, 4, 5 groups of 2, which means there's going to be 5 x's getting multiplied outside of the square root. And no x's left inside the square root. So this is going to become x to the 5th on the outside times the square root of 1, since there's always an invisible 1 left inside the square root. But we know the square root of 1 is 1, so this is just x to the 5th. The square root of x to the 10th is x to the 5th. Now, you might notice that we could get to that result a little quicker if we really understand what's going on. Okay, the square root of x to the 10th is going to take my 10 factors of x and break them into groups of 2. How do you take 10 and break it into groups of 2? Well, that's a division problem. So take your 10 x's and break them into groups of 2. Well, 2 goes into 10 5 times with no remainder. This division problem tells you everything you need to know to simplify root x to the 10. It says we have 5 groups of 2, which means you're going to have an x to the 5th outside. And it says we have nothing remaining, which means you're going to have no x's left on the inside. So, as we get used to simplifying radicals with variables underneath, we can sort of convert our simplification problem into a grouping problem. How many groups of 2 identical factors are there in 10 factors of x? There's 5, so we have an x to the 5th outside, and then there's nothing remaining, so we have nothing left inside. Let's go on to the next one. So in part B, we're supposed to simplify the square root of a to the 6th, b to the 14th. Now, we could write this out. We have 6 factors of a, and we have 14 factors of b. Okay. But in the end, the square root is going to break those 6 factors of a into groups of 2 and pull out a single factor for each group of 2. So we need to break these 6 factors of a into groups of 2. All right? And then we need to do the same thing with b. We need to break these 14 factors of b into groups of 2. Now, instead of writing it all out, let me just do the division problem. I have 6 factors of a that I need to break into groups of 2. 2 goes into 6 3 times with no remainder. So that means I'm going to have an a cubed on the outside, since I have 3 groups of 2, and then I'm going to have no a's left on the inside. Same thing with the b to the 14. I need to break 14 b factors into groups of 2. 2 goes into 14 7 times with no remainder. That means I'm going to have a b to the 7th on the outside, and because there's nothing left after I break my b's into groups of 2, I have no b's on the inside. So my overall result says that the square root of a to the 6th, b to the 14th should simplify to a cubed b to the 7th. And because I have no remainder after I make my groupings, there's nothing left under the square root. For part C, we have to simplify the cube root of y to the 12th. So the only difference here is that we have to break our 12y factors into groups of 3. To do that, I'm going to take my 12 factors and divide them or break them up into groups of 3. 3 goes into 12 4 times with no remainder. This 4 here tells me that I have 4 groups of 3, which means I'm going to get 4 factors of y taken outside of my cube root. This 0 tells me that I have no factors of y left underneath the cube root, which means I don't even need to write the cube root in this case. So if we put this all together, we see that the cube root of y to the 12th should be equal to y to the 4th, with nothing left under the cube root because we had no factors of y left. For the last part of this example, we have to deal with the 4th root of 16 t to the 4th. So in this case, we have a coefficient to deal with. Okay? When you're simplifying 4th roots of regular numbers, okay, not variables, the trick or the idea is to use a factor tree. So for the 16, I'm going to have to factor it down. It's 4 times 4, and then each 4 gets factored down into 2 times 2. And then because I'm dealing with a 4th root, I have to look for groups of 4 in here, which it just so happens there are 4 groups of 2. So that's going to give me a single 2 on the outside, with no factors of 16 left on the inside. Next, I have to worry about my t to the 4th. Okay, so I need to take this t to the 4th and break it into groups of 4. So I have 4 t factors which need to get broken into groups of 4. 4 goes into 4 one time. This means I'm going to have a single t on the outside, and because there's no remainder, I'm going to have no t factors left on the inside. So t to the 1 gets pulled out. So let's put it together. The 4th root of 16 t to the 4th equals, because of the way 16 factored, I ended up with a single 2 outside of the root. Because of how many groups of 4 we have in t to the 4th, 1, I also had a single t outside of the root. But that took care of everything. There's no factors of 16 left. There's no t's left. So that's my final result.